All right, so for this part of the video, we're going to look at reverse percentages. All right, to find a reverse percentage, it's pretty easy. A reverse percentage is like instead of looking for um, an original amount, instead of looking for, you're looking for the amount you started with, basically. You're looking for the original amount. So they might tell you like a percentage and then tell you how many of that percent actually what that percent actually represents, but you still don't know the original amount. Like, and for instance, right here, it says you drive a bus for an after school care program. You take 70% of the children you pick up to an after school karate program. If you take 14 children to karate, how many children did you pick up? So, like, it'll give you a percent, but it won't tell you how many kids you had in all. Like, your total's missing, basically. You only got like a part. So I already know that this 70% is only 14 children, but I don't know what the entire 100% is. In other words, like how many children got on the bus in all. I know 14 got off at the karate center, but we don't know how many children got on the bus. So here you're missing the original amount or the total. So what we're going to do to find the total or the original amount is you're going to use the percent given, like 70% was given in that bus problem. And we're going to use the part given. So remember, we're missing the total, we're missing the whole picture. We're only going to get a part of the picture, okay? Not the whole picture. So what you're going to do is you're going to work backward to find the original amount. So instead of multiplying by the decimal form of the percent, you're going to work backwards. So we've always multiplied, okay? Multiplication, multiplication. And it's through all the other videos we multiplied. But what I'm trying to tell you guys is if you have to find the original amount, they only give you a part to start off with. A part and a percent, divide. Okay? If you get a part and a percent, work backwards and divide. Gosh, sorry guys. All right, you're going to work backwards and you're going to divide. But if you get the total and a percent, you're going to work forward and multiply. And that's up here. Okay, let me get back to it. Okay, so if you get total and a percent, you are going to multiply. Like here, I know the total amount of people in the circuit was 400. Here, I know the total amount of sales was 12,000. Okay, but you can multiply if you get the total and the percent. You might want to write this down somewhere. But if you get the part and the percent, you're going to work backwards and do the opposite of multiplication, which is division, okay? All right, so we're going to take a look at number one. I want you to read through it. And remember what you're going to do. Hold on 1 second, guys. Okay, so what you're going to do is you're going to take the part that you were given because we got a part and a percent. I got part of the children who caught the bus. Not all of the children who caught the bus. We're going to take that part, which is 14. Okay, this is not all the children that caught the bus. And then we're going to divide by the percentage given, which is 0.70. All right, so you're going to take 14 and divide it by 0.7. And let's take a look at it. Get back to my calculator. 14 divided by 0.7, and that's going to be 20. So it's telling me that although 14 children were dropped off at the karate program, 20 students got on the bus. Okay? So 20 students got on the bus. All right, and then number 2, it says you are the shift supervisor at a local restaurant. You note that 15 employees work on Sundays. Okay? This, I told you, if you see this or the word that, it's going to refer back to that previous statement. So this is going to refer to the people. This is going to refer to the people it just got finished talking about. So this, which is 15 employees, that's what we just got finished talking about, represents 30% of all restaurant employees. It doesn't represent all of them, it only represents 30% of them apart, okay? How many employees does a restaurant have? So what you're going to do is you're going to take the 15, the part that you do know, and divide it by that percentage that 15 represent. So 15 represents 30%. So we're going to divide it by 0.3. We're going to change it to a decimal. So we're going to do 15 divided by 0.3. And let's see. Hold on, I punched it in wrong. 15 divided by 0.3. And we get 50. So there are 50 restaurant employees in all. Okay. All right, let's take a look at number 3. You work as a project coordinator for a design company. On one project, the status report shows that 15% of the work was completed in 90 days. Okay. So only a piece of it was completed in 90 days. It took 3 months for 15% of the work to get done. All right, so if the work progresses at the same rate, how many days will be required to complete the remainder of the project? So I don't know. Let's ask them about how many days it's going to take to do like the whole thing. So again, I'm only giving a part. I'm giving 90 days, okay, and the percent. So 90 days represents 15% of that whole thing. I don't know how many days in all it's going to take. So if I don't know how many days in all, if I don't know that total amount of days, I'm going to work backwards and divide. I'm going to take the days I know, which represents the part, and I know 15% is only those 15% of the work was completed in 90 days. So 15% represents those 90 days, okay? So I'm going to divide it by 0.15. So I'm going to do 90 divided by 0.15. And we get, it will take 600 days to finish that project. Now I'm just going to divide this by 365 to see. It's 1.6 years, okay? Yeah, it's 1.6 years. That's about a year and 7 or a year to 7 months or a year and 8 months. Somewhere in between that to get finished with that project. All right. I'm going to put 600 days in total. All right. All right. So let's take a look at the next one. You are installing ductwork for a new heating and cooling system at a treatment center. A project summary shows 30% of the installation was completed in 15 days. If the installation progresses at the same rate, how many days will be required to complete the remainder of the installation? So be careful. This time I don't want the total, I want the remainder, okay? But I can't get the remainder unless I take the total, unless I have the total and can subtract the days already, the days that they've already worked. So I know one thing. I know the days already worked. It's 15 days. They've already worked. So I just need to find that total so I can subtract and see what my remainder would be. How many days are left. Now this is different from the problem above. Sorry about this, guys. My pen is not doing correctly. This says how many days we require to complete the Oh, it's the same thing. The remainder of the project. Okay, I didn't see that. Okay, so remainder of the project. Okay, now it's 600 days to complete the whole project. Okay, now it takes 600 days to do the whole thing. I didn't pay attention to that one when it said remainder, so it's the same type problem. I'm glad I went back and looked at it. Okay. So it takes 600 days to complete the whole project, but they've already been working for 90 days. So what you're going to do is you're going to subtract 90 from 600. Let me write this down. Already, if I can erase it. These are the days already worked. Okay. So that tells that we still have 510 days left to complete the job. Okay. So it is the same type of problem. All right, so let's find the total first. I'm going to work backwards. Well, how many days have been completed already? 15 days. And those 15 represents 30% of the job. So you just take 15 and divide it by 30. Excuse me, 0.30. And again, okay, well, that's going to be 50 days. So basically, it's going to take 50 days to complete the whole thing. But they've already worked for 15. So now I just need to do 50 minus 15, which is 35 days are going to be left. Okay? 35 days going to be left. All right, let's take a look at number 5. All right, you are a manager at a local grocery store, and you estimate that 15% of customers will purchase a special item on display near the registers. So at the end of the day, 60 customers purchased a display item. So how many customers came into the store that day and did not purchase a display item? Okay, so I just don't want to know how many customers came into the store. I need to figure out how many customers came in the store but didn't get a display item. I know 60 of them got the display item. So it's got to be some amount minus 60. Okay, so these were the 60 that got the display item. And this is going to represent these that did not buy a display item. Okay, but you got to figure out how many came in the store in all. So what you're going to do is take the number of customers that came in the store, subtract the 60 that got the display item, and it's going to leave you with the people that did not buy a display item. Now, the question is, how do I find how many people came into the store? Well, you take the part that purchased a display item, okay? So 60 customers purchased it, and it represents 15% of them, okay? So when I get this number, it's going to tell me how many people actually came in that store. Find my calculator. Okay, here we go. All right, so we're going to do 60 divided by 0.15. 400 people came in the store. Okay, 400 people came in. So you're going to take 400 people that came in, subtract the 60 people that bought the display, and I know that 340 people did not buy a display item. 400 people came in, but out of those 400 people, 60 bought the item and 340 did not, okay? I hope this makes sense, guys. All right, thank you.